Okay, so as you know that for descriptive statistic, right, when you have the data and you could like to make it how can I say, you could like to present the data in form that is easy for the people, for other people to understand. So such memory to data which may be tabular, graphicals, or numericals are referred to as descriptive statistic. But today's, remember that in the previous lectures, we learned the way to graphicals for describing one variable, right? So today we learn the way to present for two variable. And for the second point, it is numerical methods for describing data. Um, there are three main part measures of center tendency, variant, and relative standing. So it is line number 3. It is clear to you? Can you see my screen?
Yes.
Yeah. Okay, thank you so much. So when you look at to the graph in here, you can see that for descriptive statistics, we like I just said before, right? Descriptive statistics, we can graphical or we can use numerical methods to present the data in easy way for other people to understand. So there are two main parts, graphical or numerical methods. And in the lecture number 2, in these lectures, we focus on the way to present two categorical variables. For the first part, it is cross tabulation table. So when you look at to the table in here, it is cross tabulation table. When you look at to the table in here, can you answer my question? What is the number for the variable? How many variable in here?
3.
3. 3. Sure.
2.
3 or 2?
3. 3.
3. Now for when you look at to the column, to the first column, when you look at to the first column, yeah, see, is this investment category, stock, bonds, or cash? So it is one variable. And what kind of this variable? Quantitative or qualitative?
Qualitative.
Yeah, for the first column, it is some kind for investment category, and it is qualitative, right? And what about the the when you look at to the first row, when you look at to the first row, see, you have inverter A, inverter B, or inverter C. So it is one more variable in here. It is the number of inverter. See? So in here, we have two variables. The first one is this investment category. And for the second one is this inverter. Is this clear to you?
Yes.
Okay. So when you look at to the first to the second column, look at to the second column like that. You know that for the first inverters, how much for stocks, bond, or cash, and the proportion or the ratio is different for the inverters, letter B, right? Bond, cars, and stock. It is different for each inverter, right? So this is the first way to present the data by using cross tabulation table. Or other way, we can use the graph, right? We can use graphical methods. And in here is this cluttered horizontal bar chart. And we have the note in here. We can use vertical bar chart. And when you look at to the graph in here, there are two main categoricals, right? Inverter A, inverter B, and inverter C. And for each inverters, you know that how much for stock, bond, and card. Compare with the cross tabulation table. Which one is easier for you to understand? Compare cluttered horizontal bar charts and cross tabulation table. Which one is better for you to summary the data?
Cross tabulation.
Cross tabulation. Actually, when you look at to the cross tabulation table, it's very easy for you to know exactly how much 46, 32, and 15, right? But when you look at to cluttered horizontal bar charts, it's not clearly for each part, for each stock, bond, or card, for each inverters, right? And but when you look at to the color bar in here, it is easy for you to compare each stock for compare the stocks for each inverter, right? With the bond and card, it is easy for you when you look at to the color bar in here. So it is another way to present the data. And for the next stackable bar chart, for each column, it is combined for stock, bond, and card for each inverter. And in here, when you look at to the stackable bar charts like that, this is easy for you to compare total, right? Oh. So when you look at to the H bar chart or H graph, you can see that we have to denote for the vertical line and the horizontal line. We have to present the short meaning for each vertical and horizontal line. Okay, so this is more discussion. What is bad about the following graph? What is bad about the following graph? How many variable in here? When you look at the graph in here, how many variables?
Two.
Two. Yeah. For the vertical line, this is the number for some things, and for the vertical line, it is first quartile, second, third, and fourth. And for each color, it is the areas, right? For each color, it is for areas. And what is bad? What is bad about the following graph? It is easy for you to compare the total for the total spanning in only area.
No.
Yeah, right. Because maybe when you use stackle graph, right? It sum up on the all kind of color, right? So it's easy for you to compare total spannings for 3 areas in here. But when you look at to the stackled bar chart in here, it's just easy for you to compare each area, right? And we can exploring graph years in this graph. You can do it by yourself. One more way to present your data is a scatter plot. So what is scatter plot? For scatter plot, this is used for pair observation. I mean 2 observation taken. Remember, that's only 2 observations taken from 2 numerical variable. And for 2 axes, we have dependent variable and independent variable. But in the second lecture, I mean this lecture, we not focus on which one is dependent variable and which one is independent variable. We will discuss in lectures of linear equation. Okay. So we have an example in here. When you look at to the table in the left-hand side. When you look at to the table in the left-hand side, it is average SAT score by state 1998. We have the first column for maybe it is areas, right? For the second column, it is verbal, and for the last column, it is for math. So how many variable in here? How many variable in here?
2.
2. Which one? The first is
Area.
area, sure.
Verbal scores.
Yeah. The first one is verbal score, and for the second one is math. But for the first column in here, it's just each observation, right? But we cared about the verbal and we cared about math score for SAT. So we have some observation in here, and for each observation, we have the value for verbal and math. So when you make the how can I say, scatter diagram indicate in some point in here, for the first point like that, it is about 470 verbal score, 400 and maybe it is the smallest? Is it smallest? So maybe it is for Georgia. Here, this point. Smallest point for Hawaii. Let me eraser. Okay, the smallest point for verbal is 483. So it is 483. It is smallest point.
Yes.
For the smallest point in here is 483. 483, and for the mass it is 513. So maybe I add this when you look at to the scatter plot in here, how wide at this point? It makes sense more than for the lowest point in here. For the lowest point, maybe it's for Georgia's, because 486 and 482 for mass is makes sense more than this point. So yeah, it's lined for the vertical line. Vertical line, you show the mass score, and for the horizontal line is so for verbal score. And when you make some point, you can see that when you look at to the some point in here, you can see that is indicate a positive relationship between mass and verbal score. How? Why? Why is positive relationship? Because you can see that for some point in here, it's not exactly, but it's focused on the straight line like that. It's line focused on the straight line like that. And for the straight line in here, you can see that's when the mass increase. When the mass increase, so the verbal score increase too. So it is positive relationship between mass and verbal score. Higher mass score are associated with a higher verbal score. The relationship is not perfect in that all points are on a straight line. However, the general pattern of the points and the trending suggest that the overall relationship is positive. And sometimes it is no relationship, like that, straight line like that. And sometimes it is negative relationship. Negative relationship is mean that when the verbal score, when the mass increase, but the verbal score is decrease. So in this case, it is negative relationship. And in here, it is positive relationship. Okay. Is this clear to you for the scatter diagram?
Yes.
Okay. This is the way to analyzing scatter plot. First of all, you have look overall the pattern, form, direction, strengths, and after that, find out the outlier. So what is outlier? What is outlier? Sometimes a data set will have one or more observations with unusually larger or unusually smaller values. So the extreme values are called outliers. Maybe in here, like that, maybe some point, we have 1 point in here compared with the other. So I call here it's an outlier because it is unusually larger or smaller compared with other values in your data sets. Okay, so it is a way to descriptive statistics by use graphical methods. So in here, we will move to the second part. This is numerical method to present the data. Okay, so we have 3 main parts. So in here, we will present several numerical measures that provide additional alternative for summarizing data. We start by developing numerical summaries measure for datasets consisting of a single variable. So we have to focus on 3 parts. The first one, center tendency, variation, and relative standing. Relative standing, variation, and center. So perhaps the most important measures of location is the mean or the average value. Mean or the average for the average value for a variable. So the mean provides a measure of central location for the data. This is the sum of the measurement divided by the number of measurements contained in the data set. And I think it is very familiar with all of you for the average of the set. And here is the formula to find the sample mean. Sample mean. In this lecture, I think we have to distinguish the difference between the sample and population. Population and sample. What is the difference between population and sample? Just learn in the previous lecture. What is the difference between population and sample?
Population is the whole group.
Yeah, the whole group, and the sample.
It's small group.
Yeah, it's just small part includes which contained in the population, right? Maybe it's the population here and the sample is just smaller group like that. So we have some notation for the mean of population and the mean of sample. For the mean of population, we just sum up on the value in the population and divide it by the sign of population. But for the sample, the same formula, but we denote by X bar. This is for the sample mean, X bar. Sample mean. But for the population mean, mean of population mean. We denote by mu, like that, like letter M. Is this mu? Okay, so we have a little bit different in the sign or in the symbol for population mean and sample mean, and you have to remember the sign in here. But the formula, for the formula is all the same. You have to sum up all the observation and divide it by the sign for population and for the sample corresponding. Okay, so we have an example to we have 1, 2, 3, 4, 5, 6 observation in here. We have 6 observation in here, and can you help me to find the mean? And you can type your answer in the box chat. What is the mean for the data set? Sorry, how can I, okay, so I can see the answer in here. Is this 8.3? Is this the mean for the data set in here? Okay, and I think this is easy for you. So the mean in here is 80. 83 is the mean for the data set in here. And the question is, how could the formula change if the data represent a population? So as I told you before, the formula for computing the mean of a population remain the same, but we use different notation to indicate that we are working with the entire population. For the population, the mean denotes by mean, but for the mean of the sample, we denote by H bar. So it is a little bit different for the mean. Okay. Next part is the median. The median is another measure of centers location. The mean is the values in the middle when the data are arranged in ascending order. I mean, it's order from the smallest to the greatest. And we have the notation in here. This is the middle values. So we have some K. For the first part, when you have odd number of observations, so middle values of sequence, but sometimes it is even number of observations. So you have to take the average values of two midpoint. Okay, so we have an example in here. For the raw data, we have 5 observations. See, we have 5 observations, and the sign for data in here is 5, and this is odd number. See, odd number. So when you for the first step, you have to order the data from the smallest to the biggest, right? Or greatest for the largest. You have to order it from the smallest to the largest value, and after that, because 2 before and 2 after, so number 3 and 22.6 is the median for the data set. And you can use the formula of positioning point, sign +1 and divided by 2 to find the midpoint after order. So the key for the mean is the midpoint after ordering. And we have another example when the number of observations is even number. In here we have 6 observations, so it is 6, it is even number. So in here it's very hard for you to find the midpoint, right? Because we have 2 midpoint. It is 77.7 and 89. So in here you have to find the average value of values in position number 3 and 4. So in here, what is the median in here? Medians will be equal the average of 2 midpoint over 2. Is this clear to you? For the median.
Yes.
Yes.
Okay.
Yes.
Remember that mean is its average, but median is the midpoint after ordering. It is sometimes makes a mid-text. Median is the midpoint, but mean is the average value. Or median is the midpoint. Midpoint after ordering. So here is a different. Okay, next one, it is the most. The third method of location. The most is defined as follow. The value that occurs most often, not affected by extreme value. Maybe no mode or several modes, maybe used for numericals and categorical. When you look when you look back to the mean and the median, it's just for quantitative data. You can find the median and mean for quantitative data. Quantitative data. But for qualitative, qualitative. But for qualitative data, maybe for the colors, black for the colors, color hairs for hair color, is this black, brown, or green, like that? We have some qualitative data. Can you find the mean or the median when you have the qualitative data?
No.
No, right. So the mean or median is just for quantitative data. But for the most in here, you can use for numericals or qualitative data. So this is a little bit different for some numericals. Okay, so we have 3 examples in here. For the first data set, we know most, right? Know most because the H values appears only 1 times. But for the second data set, this is 4.9, right? It's appear 3 times. So this is the most for the second data set. And for the third one, it is 28 and 43. So sometimes no most, sometimes we have more than 1. Okay, so the question in here, can you give an example of most for categorical data? Maybe in my class, we can you can make the we can ask for the hair color, right? Hair color. Maybe it is black and brown, so you can find out the most for categorical data. Or sometimes it is a gender, right? For the genders. And we can guess, right? I think that the most for genders in my class is it girl or boy? Class, can you guess?
Girl.
Yeah, girls. Yeah, so it is some example for categorical, for most for categorical. And you can take another example by yourself. The mean, the median, and the most are appropriate for which type of data? Are more appropriate for which type of data? Class? We have 2 kinds of data, right? Quantitative and qualitative. So is it appropriate for
Quantitative.
quantitative data? Okay, so this is the last for center tendency. For center tendency. So let's move to the second part. Is this measure of variant or variability? So the simplest measure of variability is the range. The range is the difference between the largest and smallest observation, and simple to compute and interpret, affected by outliers, and is ignore how data are distributed. So when you look at the data set in here, what is the range for 2 data set? What is the range for 2 data set?
3.
3, yeah, different. 10 minus 7 equal to 3. And for the second data set, it's 3 too. But when you look at to the distribution of data set in here, it is different from 2 data set. For the second data set, a lot of people get 10 points, right? But for the first data set, it is 2 people for 8 type of data, 8 type of point. So when you look at to the range in here is different. Sorry, it's the same, right? But the distribution of data set is different. The variance is measure of variability that utilize all the data. Remember that I just said you before the mean for the first notation. Is this the mean for? Do you remember? I just said to you before.
Sample.
H for mean for sample. Yeah. And me, is it the mean for? Population. Okay. So when you look at to the data set in here, what is the range for the data set? Class? What is the range for data set? H, right. What about the median? What about the median?
H.
Median, yeah, median it is the midpoint after ordering, so the median is H, and the mean is H.3. Right. So the variant is scale or is measured. The difference between H observation and the mean is measured the different H observation and sum up all the difference between all observation with the mean. And here's the formula to find the variance of population and sample. And remember that in here, the notation for population variant and the notation for sample variant is different, right? It is called sigma square for population variant, and it is as sample variant for sample, right? And it is the population size and sample size. HI in here is observation. And we mean, but for bar in for sample. So when you look at the formula in here, one more time, the variance is the different, total difference between observation and the mean. Okay. It is clear to you? The meaning for
Yes.
the variance. Class, it is clear to you?
Yes. Can you
Can you hear me?
Teacher. Explain
Cô-
again.
Mạng ơn cô có bị giật giật kiểu gì ấy cô ạ?
Okay. Any questions about the variant? Okay.
No.
For standard deviation, it's quite easy because it's based on the formula. Yes.
Cô ơi, mạng của cô bị giật đấy ạ.
Any question?
Cô ơi, em không nghe tiếng. Nó có bị giật giật.
I think you so I follow. I look up to the podcast because I can hear you clearly. Okay, so can you hear me clearly right now, class?
Yes.
Yes. Okay. Okay, so I mean, before I told you about the meanings of variant. Just take a look about the standard deviation. For the standard deviation, it's just a positive square root for the variant. This is variant. Variant. So standard deviation is just the positive square root of variant. And this is the notation for standard deviation of population, sigma. And S is the notation for sample standard deviation. So when you look at to the formula in here, when you look at to the formula, the meaning for standard deviation and variant is quite the same. It's matter the difference between each observation and the mean. Difference between the values of each observation and the mean. So it is the meaning for standard deviation and variant. is measure the difference between each observation and the mean. Can you hear me clearly?
Yes.
Okay.
Teacher,
Yes.
can you explain again the variance?
The variant.
Yes.
The variant is measure. It's measure. It's not measure, but it's based on the different. Here's is the different, right? Different is the difference between the value of each observation and the mean. In Vietnamese, nó đo sự sai khác giữa tất cả các cái quan sát so với gì ạ? Giá trị gì? Mean là gì?
Trung bình.
Giá trị trung bình. Nó tính cái sự sai khác giữa các cái giá trị quan sát đối với giá trị trung bình. Xem là khác nhiều hay là khác ít so với cái giá trị trung bình. Okay. Here we have the figure in here. When you look at to three figure in here, and I just said to you before, when this form is normal distributed, right? Normal distributed. So when you look at to the three figure in here, the range for the this is the first line, this is the second line, and this is the third line. Now, what is the range for the first line? What is the range for the first line? Class?
8.
8, right. Smallest values and largest values is the range. The range is the difference between the smallest values and highest value. And what about the range for the third line? For the third line. What is the range for the third line?
4.
4 minus 2 to 2. So the range for the third line is 4. But when you look at the third line here, here is the mean. Mean is its average value. So you can see that each observation, here is observation. A lot of observation is cover the line, right? So you can see that's the difference between each observation and the mean here. It's larger. The difference between each observation and the mean. Sự sai khác giữa các giá trị quan sát đối với giá trị trung bình. It makes the difference, larger difference between each observation and the mean. So it is the reasons why standard deviation is equal to number 2. See, but for the third line, the difference between the mean, is smaller. So it is the reasons why the standard deviation is just 0.5, because the difference between each observation and the mean is different. It is smaller. Is this easy for you to understand when you look at to the figure? Class? Is this clear to you for the standard deviation and variance?
Yes.
Any questions? And can I take another example for you to practice about the variance and the standard deviation?
Yes.
Yes.
Okay, so let's talk about the examples about the point or MEB, mathematics for economic and business. Okay, so for the first group, the point, the mark for the mass is 7, 2, 5, 1, and 6. For the second one, it is just wait. Okay, and for the second one is 4. Okay. Now we have two groups. I have to, and for the group and mean. What is the mean group class? What is the mean for the first group?
$4.2.
Mean or average value for the first group?
4.2.
4.2.
4.2.
And for the second group?
Cô ơi, second group chưa hiện lên ở trên màn hình.
Sorry. And color. For the first group, I delete the raw data set, so I just give you back 7, 2, and 4. And for the second group, it is 4, 4, 4, 4, and 4. What is the mean for the first group? Can you see my screen clearly? For the first group and second group, I have 5 observations for each group.
Yes. Yes.
Okay, so I have another group. So can you help me to find the mean for the first group? The mean for the first group is
4.
4.
4. Yeah. Mean for the first group is 4. And mean for the second group?
4.
4 too. Right. What about the range for the first group?
3.
6.
6. Right. Because smallest values is 1 and largest values is 7. But what about the range for the second group?
0.
0.
What is the range for the second group?
0.
0. Right. So when you look at the the data set for both groups in here, you can see that the point for the second group is remaining or is stable. See? Can you hear me?
Yes.
Okay. And for the first group is have the largest dispersion, nhiều sự thay đổi biến động. Okay. And for the second group is the stable. And to measure stable or dispersion, we use the variant or standard deviation. It's measures the difference between the mean and each observation. And without calculate the variance or standard deviation, can you get the variance for which group is higher than which group? The variance for which group higher? Variance for the first group or the variance for the second group? Without calculating, which one greater than which one?
The first group greater than second one.
Remember that variance is matter the difference between each observation. What? So which variance greater than which? Which group greater than which group?
The first group greater than the second one.
Yes, it is correct answer. Because you can see that the difference between each observation in here, 1 compared with 4, 6 compared with 4, 7, and 2, and 4. But for the second group, it is quite the same for each observation compared with the mean. So the variance, sự sai khác, sự thay đổi, sự chênh lệch. Okay, with some observation for the second group for the compare for the mean, it is smaller than for the first one. So it is the meaning for the variant or standard deviation. Is this clear to you?
Yes.
Okay. So here's is notation table for population and sample, and it is a little bit different. So I will spend 2 minutes for you to write down the table and remember it by yourself. Population is we, but for the sample it is X bar. For the standard deviation it is sigma, but for the sample it's just H. For the variant it is sigma square, but for the sample statistics it is S square. For the sign, the population is capital N. For the sign, for the sample, smaller group is little n. Okay, you have 1 more minute. Have you finished?
No.
No.
Okay, I want you to spend time to rewind the table in your notebook in order to take the picture. Have you finished?
Yes.
Okay, so we have an example to and it's ask you to calculate the sample variance and standard deviation. First of all, just look back the formula. It is standard deviation and standard for the variance. Okay, so I will stand here 1 minute for you to remember the formula, and after that we can calculate together. The difference between each observation and the mean divided by sum up and divided by the sign for the population. Okay, so it is the sample variance. Sample variance denotes by class. Sample variance denotes by
S square.
S square.
yeah, S square. So remember that variance is scale or is measure the difference between each observation and the mean. The mean of sample denotes by class
X
X
bar.
bar.
H bar. Sorry. Denotes by X bar. Denotes by X bar. And after that, you have to sum up. And to sure that's value positive, you have to take the square root. Because when you make the difference, sometimes it's positive or sometimes it is negative. Right. When you make the difference between each observation and the mean, sometimes it is positive and sometimes it's negative. Here we have to take the square here. That okay, and after sum up on the difference by sample size. Okay, I to you to remember the formula right now. The reasons why we have to use square here, because sometimes maybe it is 1, 2, and 3. The mean of the data set is equal to plus the mean of the data set is what is the mean for the data set? Can you see my screen?
Cô ơi, slide chưa chạy ạ.
Is this the example? Is this slide for example? And I give you an example about the data set, which includes 1, 2, 3. And my question is, what is the mean for the data set? Can you see my screen right now? Class?
Hay là cô chữ cô viết nó chưa nhìn thấy màn hình ạ?
Can you see my screen? Can you see my example clearly?
No.
No.
No. Okay, so right now, can you see my screen clearly?
Yes.
Yes.
So I give you an example, easy example. What is the mean for the data set? 1, 2, 3. So what is the mean in here?
2.
2, right? But when I measure the difference, sometimes it is -1, and sometimes it is 1. I mean, sometimes it is positive, and sometimes it is negative. So to make sure it's all the way positive, I have to use square root in here. So it is the reason so why in my formula it is h observation minus the mean after that square. See? So it is easy for you to remember the formula. Class?
Yes.
Okay.
Yes.
So let me delete the formula and one more time write this. Okay, so the sample variance denotes by s squared equal the difference between
Value of observation
observation and
mean.
and the mean of sample. And to make sure that it's all the way positive, we use the square root in here. Sum up on the difference and divided by n minus 1. Okay. But don't worry because I don't like the way to use the formula and find the sample variance and standard deviation by the hand. So I will have you to use the calculators. I will have you to use the calculators and find out the mean and the sample variance. Okay. Actually, right now I use iOS system, so you can follow by Casio FH. Okay. So first of all, you please use the most when you so I think I have to write down the guide, the some step in here, and you can do it by yourself. For Casio's calculators, for the first step, you have to choose the most button. For the most, you have next your number 3 for statistics, right? And after that, number one for variable. Okay, and after that, we have the table, and after that you can import the data. Okay. After import the data, you choose AC. So for the next step, you will calculate each sample variance or mean in your data sets by use shift 1. When you button shift 1, you have some observation, you have time, you have some distribution data and variance. So after that's number 4 variance, and in here we have some observation about the sample, sign about the mean of sample, about the mean of it is a standard deviation and of population and SH, standard deviation of the sample. Okay, so you can follow the guide in here, but in my laptop, I just use another calculators. Okay, so first of all, I will choose mode, and in here it is a third option for the statistics. Mode, statistics. Most option 3 for the statistics, and after that, can you follow me? Can you follow me, or I have to? No. Can you follow me, class?
Yes.
Yes.
So I have the calculators in my screen. So first of all, I have to choose the most for statistics. So mode, statistics, third option for statistics. Okay, and after that, I have some observation in here, and I could like to input the data with statistics editors, right? So I will choose the first option. So in here, I will import the data in the table, in my table. This is for the first column, it is the observation, and for the second column, it is the frequent for each observation, and I import the data in here, 6, 8, 10, 12, and import all the data in here. Okay, so I will spend 1 minute for you to import the data in your calculators. Have you finished? Do you want to skip this part? Cả lớp có muốn skip cái phần hướng dẫn cách sử dụng máy tính để tính mấy cái giá trị này không? Các bạn có thể tính tay nhé. Cô muốn hướng dẫn các bạn cách sử dụng máy tính calculators để tính mấy cái giá trị này, thì thay vì việc nhớ formula thì các bạn chỉ cần nhập dữ liệu vào thôi là nó sẽ ra kết quả. Chúng ta không cần phải nhớ formula nữa.
Cô làm tiếp đi hả?
Cô cứ làm tiếp đi.
Ok, các bạn import được dữ liệu vào rồi đúng không?
Vâng.
Rồi, ok. So for the next step, we could like to find some range or some mean in your data set. You choose shift. And remember, look, number 1 in here is not for statistics. See? Shift 1. Shift 1, like in your Casio calculators. Shift 1. Okay, so tính thống kê một biến. Display statistic value based on input data. Display statistic values. So in here, I will choose the first one. So you can see that in here, I have all the value that I want. Now, what is the sample mean? What is the sample mean? When you look at to the outcome in here, what is the sample mean? Class.
10.1.
10.1, right. What is the total value?
101.
101, right. And in here, because it is the sample variant, the calculators, it don't know your data is from the sample or from the population. So it gives you all for the variant. But it is the sample variant. So what is the sample variant in here? Sample variant denotes by S squared. So what is the value for sample variant?
6.76.
See, 6.76, it is the sample variant. And what about the standard deviation of the sample?
2.601.
Yes, 2.601. See, this is easy for you. Just import the data, and after that, take the value of sample and sample variant and standard deviation without computing by your hand.
Em thưa cô có thể làm trên một cái máy tính khác được không ạ?
Sorry, because I just have only calculators in my laptop, so it's hard for you to use another. Or if you have Casio, you can look at the guide in my slide. Or if you have I don't remember FH Casio, so you can choose option. I remember when you choose option, it will give you all the values like that. Cô không nhớ chính xác, nhưng mà nếu mà các bạn có cái máy tính mới nhất ấy, FX bao nhiêu ấy, VNX à, thì các bạn sẽ không chọn shift 1 nữa mà các bạn sẽ ấn vào cái option ấy, cái OPT, OPN gì đấy ấy, thì là nó sẽ ra các cái giá trị này. Thử xem.
Đầu tiên là ấn vào 6 trước, xong là nhập số, xong ấn vào OPTN, xong ấn 2 là nó
Đúng
ra.
rồi. Đúng không? Đấy thì bạn nào mà đang có máy tính đấy mà biết cách bấm rồi thì em guide một cái dòng ở trên cái phần box chat này để các bạn ấy kiểu biết giống cô này. Ấn option xong ấn số 1 hay là số 2 thì ở phần box chat ấy.
Cô ơi, FX 570 không làm được à?
fx 570 thì em phải làm từng option. Ví dụ nhá, em có thể tính được cái sx như này ra đúng không? Em ấn shift 14. Shift 14 chưa?
Không có 4 ạ. Nó chỉ đến 3 thôi cô ạ.
3 á?
Ấn AC mới có 4 á. Ấn xóa đi rồi mới có 4 á. Nếu không nó chỉ có 3 thôi.
À, ok. Em ấn AC trước nhá, để kết thúc cái việc mà mình nhập dữ liệu vào đã nhá. Sau đó là thực hành thao tác từ shift này. Một ở đây chính là statistic environment đấy. Xong là chọn variant đúng không? Variant, các giá trị variant. Thế có 4 option chưa? Lớp mình còn ai đang có máy tính nhưng mà không tính được ra các giá trị này không?
Cô ơi, nó cái giá trị mà x sigma n tức là sao ạ?
X sigma n á. Bây giờ em đang sử dụng máy tính gì nào?
Em dùng Vinacan 570S ạ. Em ra đến cái bước ấn shift 14 cái rồi, xong rồi đến 4 thì nó có 4 giá trị, đấy là n.
Từ từ
Min.
nha, từ từ để cô viết ra, Bây giờ em sẽ có 4 option này. Thứ nhất là n này, thì mình biết là cái này là chính là cho gì rồi? Size rồi đúng không? Tiếp
Vâng.
số 2 là gì?
Số 2 là min ạ.
Nó viết luôn là min à?
Không, cái x mà nó gạch trên đầu ấy ạ.
X bar đây chính là min đúng không?
Vâng.
Cái min này sẽ dùng được cho cả population, dùng được cho cả sample nhá.
Vâng.
Bởi vì máy tính thì nó sẽ giới hạn các cái số ký hiệu mà. Rồi, number 3.
Number 3 là x sigma n ạ.
X hay là S?
X ạ.
X.
Không có S ở đây.
Sigma
N ạ.
N.
N
X
là
sigma N.
N to ấy ạ.
X sigma N. Number 4.
X sigma n trừ 1 ạ.
X sigma N trừ 1 như này đúng không?
Cái
Hay
chữ
là
N nó viết ngang hàng với cả x cơ ạ.
capital này đúng không?
Ý
Hay
em là
là
viết ngang hàng ấy ạ. Nó không phải ở dưới như thế ạ.
đây đúng không?
Vâng, cái trên cũng vậy ạ. Với cả N là chữ bình thường ạ.
N là leaders đúng không?
Vâng.
Cô cũng không chắc lắm đâu nên là em sẽ thử chọn vào cái giá trị số 3 này đi. Em thử chọn vào giá trị số 3 đấy xong em xem nó là cái nào. Em so sánh xem nó là cái nào trong các cái giá trị này.
Nó là sigma x ạ.
Sigma x đúng không?
Vâng, bằng với sigma x.
Sigma x thì chính là gì? Standard deviation.
Standard variation.
Standard deviation. Standard deviation của sample.
Vâng ạ.
Được chưa?
Rồi ạ.
Ok. Thế còn số 4 thì sẽ là gì? Số 4 sẽ là gì?
Số 4 là 2,6.
Số 4 là 2,6. Còn số 3 là mấy?
Số 3 là 2,46 ạ.
2,46. Vậy thì bây giờ nhá, N ở đây chính là standard deviation của population này. Bởi vì là chia cho N thì sẽ là standard deviation của population nhá.
Vâng.
Được chưa? Còn nếu mà là N trừ đi 1, N trừ đi 1 thì sẽ là standard deviation nhưng mà là của gì?
Sample.
Sample. Và nếu mà em muốn tìm variant nhá thì em sẽ phải bình phương cái giá trị standard deviation này lên thì em mới tìm được variant nhá. Đúng không? Thì máy tính của mình nó sẽ phải thêm một thao tác hơn là so với các cái máy tính khác. Được chưa nhỉ?
Dạ rồi ạ.
Ok. Rồi, các bạn còn ai gặp vấn đề gì không? Có máy tính nhưng mà không bấm được ra kết quả. Có bạn nào gặp vấn đề đấy không? Okay, so let's move to the last part. This is Chebyshev rule. We have some theorem. And for some theorem in here is show you the relative for some observation. I mean the distribution for some observation. Sự phân bố của các cái giá trị. Okay, so Chebyshev theorem or Chebyshev rules enable us to make statement about the proportion of data's value that must be within a specified number of standard deviation of the mean. One of the advantages of Chebyshev theorem is that it's applied to any data set regardless of the shape of the distribution of the data. The meaning for the Chebyshev rule is that it will count or it measure the number of observation line within the interval. Okay. Nó sẽ tính cái gì nhỉ? Khi mà đọc cái phần meaning đấy thì các bạn thấy là nó sẽ tính cái gì ạ? Nó sẽ tính được là có bao nhiêu cái phần dữ liệu của các bạn mà nằm trong cái khoảng interval nào đấy. Thử nhá. We have an example in here. We have the mean. The mean for exam is 72. The mean is 72. So which denotes by mean denotes by we equal to 72. And standard deviation denotes by class. Standard deviation of population.
Sigma.
Sigma equal to 4. Okay, so look back to the, we have the mean equal to 72 and standard deviation equal to 4. So the Chebyshev rule say that at least how much of observation line within the interval. So in here, let's take k equal to 2, or what is your favorite number? What is your favorite number, class? You can take any number that you like. Số yêu thích của cả lớp là gì đây? Số mấy này các bạn? The condition in here is just k greater than 1. So what is your favorite number?
5.
5. Okay. So in here, at least 1 minus 1 over 5 square. I mean, bao nhiêu đây ạ? 1 trừ đi 1/25 là bao nhiêu? Lớp
24/25.
0.96 or 96%. Có ít nhất là 96% của tất cả các cái giá trị, đúng không ạ? Of observation nằm trong khoảng line within, nằm trong khoảng từ bao nhiêu đến bao nhiêu ạ? 72 cộng trừ sai khác, cộng lớn hơn hoặc là trừ đi, đúng không? Cộng với bao nhiêu? Cộng trừ đi bao nhiêu?
20.
20. Tức là trong trường hợp này khi mà k is equal to 5 thì có tới 96%, đúng không? Số học sinh trong lớp là có điểm rơi vào khoảng từ bao nhiêu đây ạ? 52 cho đến 92. Clear chưa ạ? Có tới 96% số học sinh trong lớp có điểm nằm trong khoảng từ 52 điểm đến 92 điểm. Is this clear to you?
Yes.
And is it the same when you take k equal to 2? For k equal to 2, it is at least 75%, 75%. Số điểm thì nằm trong khoảng từ 64 to 80. Tức là nó sẽ tính được số lượng, tỷ lệ, phần trăm dữ liệu nằm trong khoảng giá trị chính xác là bao nhiêu đấy. Các bạn clear chưa ạ? The meaning của Chebyshev theorem. Nó sẽ tính cho các bạn là có khoảng bao nhiêu phần trăm dữ liệu tập trung vào trong khoảng nào đấy, cái khoảng giá trị nào đấy. Đó. Và như các bạn thấy là cái case này khi mà nó càng lớn thì cái tỷ lệ phần trăm dữ liệu của nó sẽ như nào? K equal 5, vừa nãy các bạn vừa tính là 96%. Đúng không? Nằm trong khoảng bao nhiêu ấy nhỉ? 72 trừ đi 20 là 52 đến 92 đúng không? Thì cái giá trị K này càng lớn thì cái tỷ lệ phần trăm dữ liệu nó càng như nào?
Càng cao.
Càng
cao, càng lớn.
Thấy không? Được chưa ạ? So in many practice applications, however, data set exhibits a bell-shaped distribution. When the data is believed to approximate this distribution, I mean bell-shaped distribution, the empirical rule can be used to determine the percent of data's value that must be within a specified number of standard deviation of the mean. For the empirical rules, a little bit different compared with the previous one, Chebyshev rule. For Chebyshev rule, you can apply with any distribution. Chebyshev rule thì các bạn apply được với toàn bộ tất cả những cái dạng phân phối. Nó lệch cũng được mà nó đều cũng được. Được chưa ạ? Còn đối với empirical rule thì điều kiện của nó là gì đấy ạ? Nó phải là gì ạ? Nó chỉ apply cho gì thôi? Bell shape thôi. Khi mà dữ liệu có dạng bell shape như này thì được apply empirical rule. Về empirical rules là những cái giá trị percent này là nó fix luôn rồi này. Được chưa ạ? Nó bảo là 68% of observation, có 68% dữ liệu sẽ nằm trong khoảng từ như này, 95% dữ liệu thì nằm trong khoảng như này, và tất cả almost all observation thì nằm trong khoảng như này. Tức là các cái phần trăm này là nó đã fix luôn rồi, các bạn không được phép thay đổi. Được không? Còn cái giá trị mean và standard deviation này thì cũng vẫn như vậy thôi, vẫn giống như bên kia thôi. Clear không nhỉ? Và những cái số này là các bạn phải nhớ đối với empirical rules là nó fix luôn. 68, 95. 68% of observation within one standard deviation of the mean. Thử nhá. Ở đây nó là hình gì đấy ạ? Bell shape rồi. Bell shape tức là có dạng hình chuông này, đều rồi, symmetry rồi. Đúng không? Ở đây người ta cho 505 ở đây chính là cái gì đấy? $555 mean của gì?
Của điểm toán.
Của population. Và 50 ở đây chính là standard deviation của population. Denoted by
Sigma.
sigma. Vậy thì đối với empirical rules nó fix luôn này, nó bảo là 68% of 68% của các dữ liệu của các bạn observation sẽ nằm trong khoảng bao nhiêu ạ? Mean cộng trừ standard deviation đúng không? Tức là bao nhiêu? 500 đến 600. Back lại xem đúng không nhá? Within one standard deviation of the mean. Chuẩn chưa? 68% nó fix luôn số này nhá. Tiếp 95% of all observation nằm trong khoảng bao nhiêu ạ? Two standard deviation of the mean. Sai khác 2 lần standard deviation of the mean. Tức là bao nhiêu? Từ đâu đến đâu?
450 đến 750.
450 đến 750. Clear chưa ạ? Tức là nó sẽ tính cho các bạn là khoảng bao nhiêu % dữ liệu nằm trong các giá trị từ đâu đến đâu. Và cuối cùng là gì ạ? Almost, gần như là hết toàn bộ đúng không? Observation sẽ nằm trong khoảng gì ạ? Bao nhiêu? Bao nhiêu nào?
400 đến 700.
400 đến cái gì cơ? 400 thì phải đến mấy?
700.
700 á. Rõ ràng là các cái khoảng này khi mà cái tỷ lệ phần trăm
Bên kia là
observation nó tăng
650
lên
thôi
thì
cô ạ.
cái range này nó cũng phải tăng lên chứ
thứ
đúng
hai
không?
nó chỉ 650 thôi.
Cả
không
hai
phải
nó chỉ
650.
650 thôi ạ.
À ok, 650. Vậy thì cái này sẽ phải là 700 đúng không? Thấy hợp lý chưa? Make sense chưa? Vậy thì khi mà cái số lượng dữ liệu, phần trăm dữ liệu observation nó tăng lên đúng không? Thì rõ ràng là cái độ phủ của dữ liệu này nó phải dài ra rồi. Thấy hợp lý chưa? Question. Percentiles. The last part is a matter of relative standing. For relative standings, percentile provide information about how the data are spread over the interval from the smallest value to the largest value. And we know that approximately 80% of the company, 80% of the companies are lower than individual, and approximate 20% of companies scale higher than individual. Or you can look at to the quartile. We will divide the data set into 4 parts. For the first is this first quartile, second quartile, and third quartile. So for each values in here, we can know that 20% of the observation is smaller than first quartile, and 80% of your company is lower than the third quartile. And Q2 in here is the median, or is this the mean for the data set. So for the percentile, is we have you to define how the data are spread overall the data set. And here is the smallest point, here is the largest point of your data set. Another way to present the percentile is we can use the box plot. Here is 2 ways to present the distribution of the data set. The first one is it use the shape, and for the second one is it use the box plot. For the box plot, the first point in here is it show the smallest value, and here is the largest value. And when you look at to the first figure, it is left skewed. So you can see that in here, the data sets based on the right hand side. The data sets based on the right hand side. Dữ liệu thì tập trung vào phía bên tay gì ạ? Bên tay phải, đúng không? Bạn thấy là rõ ràng là cái lớp này điểm đang khá là cao này này. Nhìn thấy chưa? Tập trung vào right hand side. So it is left skewed. Dữ liệu nó đang bị như nào ạ? Lệch về bên trái. Tập trung vào bên phải thì sẽ là lệch về bên trái. Left skewed. Ok. Và khi mà các bạn biểu diễn bằng box plot thì tất cả những cái giá trị này, cái hình chữ nhật này đúng không? Biểu đồ nến đấy, đúng không? Bạn nào mà chơi chứng khoán hoặc là coin thì người ta sẽ sử dụng cái biểu đồ box plot này, vertical box plot. Thì đây sẽ là giá trị Q2 này, Q1 này và chỗ này là Q3 với cái điểm đầu tiên này chính là smallest value và highest value, được chưa ạ? Symmetric tức là gì ạ? Lớp này đang học khá là đồng đều rồi này, không có vấn đề gì trong dữ liệu đúng không ạ? Còn right Q tức là gì ạ? Lớp này đang học hơi kém đúng không? Dữ liệu đang based on the left hand side. Left hand side tập trung vào phía bên tay ấy. Tay trái đúng không? Tay trái tức là right skill. Còn trong market thì các bạn thấy có thể là khi mà nhìn vào cái biểu đồ này thì thấy là thị trường đang bị gọi là giảm đúng không? Cái giá trị cổ phiếu nó đang giảm này, thấy chưa? Nó tập trung ở bên left hand side tức là right skill. Thì đấy chính là meaning của shape. Khi mà các bạn nhìn vào shape hoặc là nhìn vào box plot thì các cái giá trị này thì là ý nghĩa của nó biểu diễn là như nhau, chính là percentile. Khi mà nhìn vào các cái shape và or box plot này thì các bạn thấy sẽ là nhìn thấy cái xem là dữ liệu nó đang tập trung ở cái phần nào. Nó đang tập trung ở phần giữa đúng không ạ? Nó lệch về bên left hand side, left skewed hay là lệch về bên right skewed. Các bạn hiểu không nhỉ? Is this clear to you?
Yes.
Yes.
Okay. Okay, so is it the end for the second lectures? I think it is quite. It's not difficult lectures, but it is quite long because it have a lot of definition about the methods, numerical methods. For graphical methods for describing two variables, we have cross tabulation. Cross tabulation. We have cluttered. We have scatter. Cluttered bar charts, scatter diagram, and we have vertical bar charts, right? Vertical bar charts. I mean, we have some way to graphics to present the data. And for the second part, for measure central tendency, đo độ tập trung, thì chúng ta có những cái giá trị gì nhỉ? Measure central tendency. We have the mean. We have
Median.
Model.
And
Mode.
mode, yeah. And for the variance, đo sự gì nhỉ? Chênh lệch đúng không? Chênh lệch thì chúng ta có cái gì à? Range. Rõ ràng là thời tiết khí hậu min nhất và mắc nhất trong ngày ở Đà Lạt thì nó sẽ cao hơn đối với lại cả min nhất và mắc nhất trong ngày ở Hà Nội. Được chưa ạ? Measure variance thì sẽ có range này, gì nữa?
Variance.
Đo cái sự chênh lệch đúng không ạ? Và gì nữa?
Standard deviation.
Được chưa ạ? Measure of relative standing tức là gì ạ? Đo cái sự gì ạ? Phân bố đi, nói chung là đo cái sự phân bố liên quan của các dữ liệu xem nó tập trung vào bên phải hay là tập trung đều hay là tập trung vào bên trái. Đây sẽ là left skewed và đây sẽ là right skewed. Thì chúng ta nhớ là có hai cái theorems là đo cái tỷ lệ phần trăm dữ liệu mà nằm ở trong khoảng nào đấy. Thì cái phần hai cái theorem đấy thì các bạn chỉ cần nhớ cho cô cái khi nào được dùng hai cái theorem đấy. Đó. Thì cái phần lecture hôm nay là khá nhiều knowledge đúng không ạ? Okay, so is there any question?
No.
Okay, so thank you so much for to be here and listen my lectures. Thank you so much.
Thank you, teacher.
And
Thank you,
yeah,
teacher.
and I think in this lecture we don't have time for the small test. So maybe in the next lectures I will prepare a small test for all of you. Okay, so we can stop here. Thank you a lot.
Teachers.
Goodbye and see you.
Goodbye, teacher.
Goodbye, teacher.
Goodbye, teacher. Thank you, teacher.
Goodbye, teacher.
Goodbye, teacher.